Agonistic behavior is a behavior seen across many types of laboratory mice and rodents. It is most frequently shown through instances of chasing, mounting, and induced flee. African spiny mice in particular have been shown to demonstrate relatively high amounts of agonistic behavior as a way to establish their dominance hierarchies. The African spiny mouse is also recognized for its ability to completely regenerate tissue as opposed to the normal scarring healing process that occurs in all other mammals. Previous research indicates that stress can have a negative effect on the process of healing, and we were interested in seeing if there was an association between stress and the process of regeneration. Since agonistic behavior is a common behavior of spiny mice and is a form of social stress, we were able to use the incidence of agonistic behavior as the independent variable in our experiment. The use of spiny mice for a model for regeneration is expanding. Therefore, it is imperative to understand whether behaviors that are causing stress may be having an effect on their rate of regeneration. Therefore, we hypothesized that mice who experience higher amounts of agonistic behavior would have overall slower rates of regeneration compared to mice who experience less agonistic behavior. The first portion of the experiment consisted of live coding each cage 3 times a week for 3 weeks in order to determine the dominance hierarchies. Once those were established, we took a 4mm biopsy in one ear of each mouse and marked the first day of the regenerative healing process. Measurements of each ear were taken every 5 days until full regeneration was achieved. During the regenerative process, we coded pre-recorded videos of each cage to establish the incidence of agonistic behavior across the cages according to the ethogram that can be seen in Figure 3. Upon examining the results and referring to Figure 4, we can see that at the individual level, the subordinate mice had much lower rates of regeneration compared to the dominant mice. When examining the results at the cage level, we did not find an effect between the overall agonistic behavior and overall rates of regeneration. However, in reference to Figure 5, it was interesting to see the frequency of the different types of agonistic behavior and the times of the day that they occurred the most. Ultimately, from these results, we can conclude that animals who were subordinate and experienced higher amounts of agonistic behavior had overall slower rates of regeneration compared to their dominant counterparts who experienced less agonistic behavior. This was a trend we observed across every single cage. Based on existing research, we concluded that this delay in regeneration may be attributed to the overactivation of the stress response in the mice who were experiencing higher amounts of social stress. Moving forward, we are currently in the process of replicating this experiment in order to acquire a larger sample size and run statistical analyses. We expect to find results similar to what we found in this experiment and ultimately hope that our research has contributed to the future use of spiny mice as a model for regeneration. Future work in the field of regenerative medicine should consider the effects of social stress regardless of the model for purposes of maintaining internal validity. However, examining the effects of social stress on regeneration in spiny mice is an important piece to understanding the underlying mechanisms of the overall regenerative process.